So if we were to say the airplane is heading, heading means that is actually V prime. Okay? Heading is the V prime. So, and it's heading due south at 500 kilometers per hour. So, even though the airplane is aiming in this direction, right, south, because of the wind, if the wind begins to blow, right, from southwest, so it's blowing from southwest at speed of 100 kilometers per hour. So, since it's blowing from southwest, it's blowing towards northeast. Okay, and this is our U. Okay, and because my U is actually splitting southwest, so southwest is from here going that way, it's blowing northeast. This angle here is 45 degrees. Okay, I will draw this thing a little bit bigger here so you guys can see it better. Okay, so if you want to, you could scale this thing out so that this, like, you can make 100 kilometers per hour into, I guess you could make it as like 1 centimeter is equal to 100 kilometers per hour. Then in that case, this is your V prime. Right? This is your V prime. And 45 degrees towards, now I'm just eyeballing this, so I'm not like doing this exact. So, and it's 100 kilometers per hour, so it is only 1 centimeter this way. So this is my U. Okay? So if I were to break this U up into X and Y components, okay, it's going to look like so this is my UY, and this is my UX. And this here is 45 degrees. Okay? So we should be able to calculate the UY and UX. And UY is U times sine of 45 degrees, which is 100 times sine of 45 degrees. So UY is equal to 70.7 kilometers per hour. And since it's 45, my UX is also same as my UY, which is 70.7 kilometers per hour. All right? So the actual path that plane takes is going to be my V. So V prime plus U is my V, and this is the actual path that plane takes. This is my V. Okay? So we can basically say still the same thing. V is equal to, right, V prime plus U. Instead of using any other, subscripts, I think this is probably the easiest way to view things. Okay? So if we could find the V prime and U in terms of X and Y components or Cartesian form, V prime is pretty easy, right? So V prime is equal to 0x hat minus 500 y hat kilometers per hour. Then U, we already found the components, and that is positive 70.7 x hat plus positive 70.7 y hat kilometers per hour for the wind. So when I add these, right, when I add these, what do I get? My V now is equal to 0 plus 70.7 is 70.7 x hat, minus 500 plus 70.7 is minus, right, 429.3 y hat. Okay, and that is kilometers per hour. So for part A, it says calculate the magnitude and direction of V, right, of the ground speed. So here we already know the Cartesian form, so we could find the magnitude, obviously. The magnitude is equal to, right, square root of 70.7 squared plus 429.3 squared. I know it's negative, but when you square the negative, you're going to get the positive anyway, right? So if you work that out in your calculator, I think you'll get something like 435.1 kilometers per hour. All right, so that's the magnitude, obviously. So that's the ground speed. So this is the ground speed, which means this is the speed that is measured from the stationary person on the ground. Okay? Now, let's take a look at the actual direction. Now, the direction can be calculated two ways. One way is to calculate this little reference angle here. I could call that beta, right? But the proper angle in theta is basically this whole thing right here, right? And beta, since that's in fourth quadrant, right, you can calculate that using the x and y component of the v. All right. So to calculate beta, your beta is equal to tan inverse of, right, opposite, which is basically the vy, right, over adjacent, which is the vx, right? So if you plug in the values, right, you get tan inverse of, right, vy, which is negative 429.3, over vx, which is 70.7. So if you calculate that, your beta comes out to negative 80.7 degrees. So since this is the reference angle, beta, you can say my theta is equal to, right, 80.7 degrees south of east. You could say that. That's perfectly legitimate. Or simply, you can say my theta is equal to 360 minus the absolute value of beta, right? Which is basically 279.3 degrees. So you could do it this way, you could do it this way, or you can even do, the direction is 9.3 degrees east of south. So I could accept any of these three directions as legitimate directions. So I could accept this, 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 and since it's in fourth quadrant, I could even accept this, because that is a negative angle, and negative angle is actually a proper angle for fourth quadrant. All right? So we can finally say my V is equal to 435.1 kilometers per hour, right, comma, theta is equal to 279.3 degrees. Again, the direction, you can give it to me in any of these four. So that was part A. Okay. Now, for part B, they ask, how far off course it will be after 10 minutes if the pilot takes no corrective action, right? So instead of being here, the plane's going to be here, right? So how far away is the airplane instead of where it should be, right? How far off course will it be? Well, we know 10 minutes is only 1/6 of an hour, right? So since delta x is equal to, right, VIT plus 1/2 AT squared, this is again equation number 2, there's no acceleration for the wind. So since this is blown off course by the wind, our distance that we actually are off by, so this is the distance that we are off by, is equal to u times t. U obviously is 100 kilometers per hour, and time, t, is 1/6 of an hour, right? 10 minutes is 1/6 of an hour. So if you could see that hours will cancel out, okay? And this will come out to 16.67 kilometers. That distance is 16.67 kilometers, right? I guess southeast, okay? Southeast from where it should be, okay? So it's 16.67 kilometers, right, off from destination, right? (45 degrees south of east). So that's that's more than 10 miles off course, which is like 16.2 kilometers would be 10 miles, and that's like 10 miles off course. Okay. All right. Any questions? All right. So now this thing asks for part 2, in what direction should a pilot aim the plane if it wants to fly due south exactly? So instead of flying south this way, so the wind makes them drift this way, so the actual path is going to be like this. Now, in order to do a corrective measure, the pilot should actually aim the plane sort of towards the wind, hit right this way, so that the wind will blow back into its course, so the actual path will be straight down south. All right. So don't think it is going to be this angle. It won't. Okay, so it's not going to be exactly the same angle as this. And most commonly wrong answer will be that. It's like, well, it's the opposite of that, right? And the answer is no. So don't think that is the correct measurement. So here, we know we can fly this airplane at 500 kilometers per hour a certain way this way, right? And then, so this is our V prime. Then the wind, again, is U, is going to fly 100 this way, right? This is U. Now the actual plane will fly straight down south. So this is our V now. Okay? So we have to actually find this in component form of Vx, V prime X, and V prime Y. We already know what this is of Ux and Uy, because that's not going to really change. And when I add them up, I should have a 0 x hat for V and something negative for my Vy. Okay? So let's try to figure out what the component of my V prime is. Okay? Now, obviously, we're not going to know the exact value because we don't know what this angle is. Right? We have no idea what this angle is. So we're going to call this angle beta. Our purple beta right here, right? So if we were to find components of that beta, I'm going to redraw that, okay? I'm going to redraw it somewhere off the thing so we can actually see it better. Let's say, like, here's my V prime, right? So here's my V prime Y. Maybe I should write down the V prime here. So here's my V prime Y. And then here's my V prime X. Okay. This here angle right here is my beta, and this is the right angle right here, obviously. So, if we were to look at this, right, my V prime X is equal to, right, V prime times cosine of beta. But it is going in the negative X direction. All right? So this has to be negative value. So my V prime X is equal to negative 500 cosine beta X hat. I'm running out of purple. Let me see if this purple works. So this is my V prime X is equal to negative 500 cosine of beta X hat. And similarly, my V prime Y is equal to V prime sine of beta Y hat, but it is going in the negative direction, so I should put negative in front of that. So my V prime Y is equal to negative 500 sine of beta y hat is what we have. Okay. Now for u, obviously it's pretty simple. Ux is equal to u times, right, cosine of 45. And we already know that is 70.7, right, x hat. And uy is also 70.7 y hat. So we already know that for u. Okay? So since we already know v is equal to, right, v prime plus u, we can write these down in Cartesian forms. My v prime is equal to, right, negative 500 cosine beta x hat minus 500 sine beta y hat. Now for u, we have 70.7 x hat plus 70.7 y hat. Now when I add these two vectors up, I know I'm going to get a v, and my v has both, well, it has 0 x component, because I'm only going to fly straight down negative y direction. So when I add these up, I should get a 0 x component. As far as y is concerned, I don't know. We could figure that out later. But this is something that I definitely know. So I can work with just this component part, because I know when I add these two up, they better cancel out to 0. Okay? So I can say v prime x, right, plus ux should equal to 0. So here, my negative 500 cosine beta plus 70.7 should equal to 0. Therefore, negative 500 cosine beta is equal to negative 70.7. So hopefully you can see that beta now is equal to cosine inverse of, right? Cosine inverse of negative over negative is going to come out to be positive, right? So, but I'll still put it in there, right? Negative 70.7 divided by negative 500. So the beta should come out to 81.9 degrees, which is not the same as 80.7 up there. Okay? That's not the same. So, in order to fly straight down south, right? In order to fly straight down south, the pilot should aim theta as 81.9 degrees, right, south of west. Or theta can also be calculated, right, 180 plus this, like 261.9 degrees is also the same, right? Or you could say theta is equal to, I guess, 8.1 degrees, right, west of south. So any of these three would be the proper angle for the direction of the aim. Now I can ask one more thing, actually. I can ask, how fast is the plane flying? What's the ground speed? Now that you know the angle, right, you can pretty much plug it in there to figure out what the ground speed is. So let's figure out what the ground speed is, right, for part B. So if we were to plug in 200, I guess since the beta is 81.9, right, you could plug the 81.9 in there, right? So we can say Vy is equal to, right, V prime y plus Uy, right? So we can say Vy is equal to, here I have negative 500 times sine of 81.9, right? Plus 70.7. So what is this purple value? The purple value is, right, so 500 times sine of 81.9, and I get negative, so Vy is equal to negative 495.0 plus 70.7. So what is my Vy value? My Vy is equal to negative 424.3 kilometers per hour y hat. So since we know that, so we know this, so my V is equal to 0x hat minus 424.3 y hat kilometers per hour. So if you want, you can actually find the ground speed, which is this squared plus this squared, square rooted. It's just 424.3 kilometers per hour. And the velocity will be this, comma, south. Just straight south. Okay? Or 270 degrees. So you could say V is equal to 424.3 kilometers per hour, comma, theta is equal to 270 degrees. I know that wasn't asked. There you go. Voila. All right. Hopefully now you can finish working on this and post it up so you have no excuse whatsoever not to hand this in because I gave you the solutions. So no excuse. All right. Any questions? All right. So that's pretty much wrapping up our chapter 3 part 2. We will start chapter 4 on I guess after Thanksgiving break. So print those chapter 4 notes pages out if you can during the Thanksgiving break. Okay? Your quiz for today is located in, let's see, it's located in, of course I can't find it. All right, it's located in current units, chapter 3. If you go to the test folder, this relative motion quiz is the one you want. Right? Only 2 pages. Look, identical except, look, the numbers may have changed. Oh my God. The direction is also a little changed. Oh my God. Okay? So first thing is draw it out correctly. Okay? Instead of 10 minutes, oh, it's 20 minutes. Oh my God. Right? So hard. Right? So those 3 questions is what you need to do. All right? If you need extra room, you could work on a separate piece of paper. make sure you could put your name down and upload it on Schoology, so you could start working on that as of today. All right? Any questions? All right, then I will stop the recording. Okay, I will stop the recording.